This time we will take a look at high availability on firepower. I'm gonna start off with a discussion of our options for high availability. It is gonna include redundancy and possibly also load sharing in certain cases. And then we will take a look at demonstration. I'm gonna show you how to configure failover between two FTD units, two virtual firepower threat defense systems. Okay, high availability in terms of firepower can be similar to the ASA deployed at two different levels. We've got the interface and system level. Now, in case of the interface level, we can deploy interfaces, physical interfaces of our devices in two different ways. We can go for redundant ports or Ether channel. Now, what is going to be the difference between these two solutions? Now, case of redundant interfaces, in this case, we're going to be always dealing with two physical ports like gig 1 and gig 2. And those interfaces, we will make them part of the same VLAN, or maybe if these are to be trunks, we will want to make sure that they are both trunks and they are connected to the same logical networks on the switches. So we will want to check if the spanning tree settings are the same between the two physical ports connected to these two physical interfaces on our FTD. And the goal is going to be to make these act more of like one logical port, which is going to be represented as a redundant interface, such as redundant 1, where this redundant interface is going to show up as up no matter which of these two physical interfaces will be active. Now, in this case, only one of these two ports is active, where the other one is standby, meaning that from the physical network perspective, it's only going to be one of these two what is going to handle the traffic. The other one is going to be waiting for, in this case, gig 1 to fail. Now, if gig 1 has some issues, it automatically becomes standby, which means that the other one becomes active and the other one starts handling data traffic. Now, note that this change on physical interfaces, it doesn't change the state of the redundant port. The redundant port looks like it is always up, and this is where logical configuration is going to be placed. Now, in case of Ether channels, the situation is going to be slightly different. Well, we will still represent two physical interfaces as a single logical port, but this port is going to be more of like a bundle of the two. So let's say that the bundle is going to be called P1, where P stands for port channel, and port channel is going to be seen as up. But in this case, we not only provide redundancy, but since this is a active setup, both of these can physically handle the traffic. We also allow for load sharing. Of course, in the previous case of redundant interfaces, the load sharing was not possible because only one of these two ports was active, where in case of Ether channels, we've got two or more, depending how many of the physical ports you choose to bundle. So Ether channel is going to be a more preferred solution in most cases. Okay, in case of the failover at the system level, which is dealing with the units themselves, like our firepower threat defense systems, virtual or physical appliances. In this case, we can use failover. It's the same failover as what we saw on the ASA, but in case of FTD, only the active standby solution is supported. Active failover is not available, at least as of 6.2.2. Okay, the other option, which is available only on two types of physical appliances for the 100 and 9300 series platforms, this is clustering. So with clustering, we are dealing with more of like an active setup where all devices that we make part of a cluster are capable of handling the traffic. So we can either go for active standby failover, or you can go for clustering if you've got those higher end physical appliances. One more option left is for our management stations for FMC. The only option available here is active standby redundancy, similar to redundant interfaces or basically active standby failover. We will have two FMCs, like FMC1 and FMC2. One of them is active, the other one is standby, and it's only going to be the active unit what is used to configure our managed devices, but in the same time the configuration is being replicated to the standby unit. So if we lose FMC1, which is active unit, FMC is gonna take over, and since the configuration was replicated in the first step, we will not lose it. We will be able to use the second FMC to configure our sensors. Okay, what we will take a look at in this session is gonna be the failover configuration. By the way, the FMC setup is not available on all platforms. I don't think you can use this option on virtual FMC. We will focus on failover configuration, and there are going to be several prerequisites here of things that must match between our appliances for failover to take place. Like on the ASA, the devices must be the same platform. They must support the same number of interfaces, which must be configured in the same way, like routed versus, let's say, inline. Okay, the firewall mode, routed or transparent, must be the same between the two systems. Software version must also match between the two units, the same as NTP configuration. Now, in case of licenses, even if they don't initially match, the device will try to make sure that the licenses will be eventually unified. So this is gonna work if you have the smart agreement signed with Cisco. It will be possible for a system to return a license to the pool and pull it as needed so that the primary and secondary devices have the same licenses after failover takes place. Okay, both devices must be managed by the same FMC, and we cannot have any uncommitted changes to those. We will do the configuration from the device management, and we will use the add high availability option. Now let's quickly take a look at this. Let's go to devices, device management. I've got two FTDs registered to this FMC. I'm gonna click on add high availability. We will call it fail V1, and I'm gonna select the device type to be firepower threat defense. My primary peer is gonna be FTD1. Secondary peer, I'm gonna say, is FTD2. Yes, we want to continue. It requires a snort process restart. And we see we have a bunch of options we can now configure. It's pretty much all about the failover link that we will want to use for this communication. Now, just a quick look at the doc.cd. For failover configuration, you would be looking at, it's going to be firepower threat defense, high availability, and scalability. We've got failover and clustering, what is documented here. So we can take a look at this document to learn about those different options. Now, if this was the interface level failover, let's take a look at firepower system management. Firepower system management, firepower management center, high availability, this is for FMC. But there is one more for the interfaces I forgot to show you. it's gonna be over there. Firepower, threat defense, interfaces, and device settings. And we would be looking at, let's take a look at, it might be actually in a different location. It's not gonna be here. Okay, let's try to find it. Let's take a look at firepower, threat defense getting started. Interfaces and device settings, it must be somewhere here, maybe regular firewall interfaces. Yeah, it's gonna be this place. So just to make it clear, once again, the interface level failover for FTD is documented under firepower, threat defense, interfaces, and device settings, regular firewall interfaces for FTD. Now the FMC HA, you can find it under firepower system management. And finally, failover configuration is under firepower, threat defense, high availability, and scalability. We have 3 different places related to high availability in the documentation. Okay, but going back to the config, I'm gonna choose gig 00, which is the only port connected on our rack. I'm gonna say that this is gonna be a failover port. And for the state link, I'm gonna say that it's gonna be the same as the failover link, which means that stateful replication is gonna be performed using this single gig 00. It's the same interface would be used for regular failover, keep alive exchange. It's the same concept like on the ASA. I'm gonna call it fail v LAN. And let's give it 10.99.99, let's say 10 as a primary IP address. We will put 20 as the secondary address, and it's gonna be /24 subnet. Okay, you could optionally encrypt this failover communication using IPsec, but I'm not gonna be doing this. I will say add, and it's gonna take a couple seconds for this change to get to the devices. Now it says configure interface monitoring options to protect the HA pair interfaces. Apply the same health policies to primary and secondary nodes of the HA pair. So this is more of like optional configuration. I'm gonna say okay. Okay, so for this stuff, you would actually look up the documentation, like monitoring high availability. You can take a look at this portion. Okay, on registration. Maybe let's scroll from the top towards the bottom. It says add the pair and configure optional high availability parameters. So configure standby addresses and monitoring interfaces. Okay, we will actually, assuming that the failover is gonna kick in, because we have just one interface available on those FTDs, which is connected to the rack. And I just want to make sure that the devices can actually communicate. We can try to get to the CLI to quickly verify this. I'm gonna say show fail. Let's just go to the Lina CLI. And let's do this on the second unit as well. Now let's say show failover. Its failover is off on FTD2, and failover is on FTD1. Okay, we will have to wait for the deployment. It is still processing this config. But going back to FTD1, we see that this is the primary unit. Failover is turned on. The default interface policy is 1, and only one interface, the physical one, is monitored. Diagnostic is not connected to the network. We won't see anything here. Still no active may detected. because the primary device assumes the active role, like on the ASA. We see that it finished processing. Let's just take a look at the health information. It says not receiving any packets. Okay, this is the old stuff. Okay, let's go back to the command line. Okay, so FTD says detected an active mate. Apparently it loaded configuration from FTD1. Okay, so config was sent from the primary unit to the secondary device initially. Let's say show IP. Right, so we see that FTD1 uses 10.99.99.10 on GigaO versus the standby device uses, the current IP address is going to be this 120 versus on one it's 10. Now if I say show failover on FTD2, it says the secondary unit failover is enabled and I am standby. My mate is active, so we should see the opposite on FTD1. It says I am active, peer is standby. And once again, I won't be able to show you the actual interface config because we have just one interface that was just taken for failover. But for the optional configuration, you see you can click on the failover instance. It shows you the information about the config. And for the monitor interfaces, this is where you would normally put the standby addresses. Because if we go back to the device management, let's take a look at the settings on one of the two systems. So you are no longer able to configure interfaces on those individually. The only place where you can change the config is going to be to do this on the failover instance itself.